All right, so we are on learning target 1.5, which is about dimensional analysis. Dimensional analysis sounds a little bit sciencey, but it's really just multiplying and dividing. You just have to know how to do it the right way so that you're basically more guaranteed to get the right answer. Most often when people are doing problems like this, they're not sure if they know, or they're not sure if they're supposed to multiply by the number or divide by the number. And what dimensional analysis does is it basically tells you whether you need to multiply or divide by certain numbers. So hopefully this works. These are all the metric prefixes that we're going to use. You do need to have some of them memorized, not all of them. So make sure you memorize centi, memorize kilo, and memorize milli. Where you might use the other ones, you might see the other ones, but those don't have to be memorized because I can remind you of them. But these are the big three that are used most often in chemistry, so you should do your best to have those memorized. Dimensional analysis is a problem-solving technique to convert between units of measure. So if I want to figure out how many inches are in something like 5.6 feet, many of you will know immediately that you just multiply that by 12, and that'll give you the right answer. The only reason you know that is because you're super familiar with inches, and that there's 12 inches in a foot, and that inches are smaller than a foot. So that if I want to make this into inches, the number needs to get bigger because inches are smaller. But let's say you don't know that, because when we get into chemistry units, the metric system, as well as later when we do stoichiometry, you're not going to know any of this stuff nearly as well as you know inches and feet. So the way that you do this is you have to always start with the number in the problem. So this is the number in the problem, so that's the number that I start with. And for dimensional analysis, you always have to show your work. Then what we do is we multiply it by a unit factor. What a unit factor does is it's going to scale it up or down in order to match the final unit. So in this case, we need to scale it up by a factor of 12. So a unit factor factors the units so that it tells you how much to scale it by. So unit factors are always fractions. So this is a multiplication symbol, and this is a fraction. I'm going to have a numerator and a denominator. The numerator and the denominator have to come out of an equality. So something equals something else. You should know that 12 inches equal 1 foot. You know that, right? So this has an equal sign between it, which means it can go in that fraction. The units have to match across the dividing line in order to cancel out. So here I have feet in the numerator because I can pretend this is over 1. I have feet in the numerator, so that means I need feet in the denominator. If you notice, I haven't put any numbers there yet. It's very important that when you do this, you do the units first and then figure out the numbers later. Whatever is across the equal symbol in your equality goes in the numerator. So in this case, it's inches. There are inches in feet. And then when I get the units straight, then I can do the numbers. You probably want to do the numbers first, but that's just because you know inches and feet really well. Later in the semester, when we start using numbers that you don't know really well, do not try to do the numbers first. I guarantee you that's the fastest way to get it wrong. So the numbers come out of the equality. So once we have the units, look at the equality. 1 foot, 12 inches. So 1 goes by foot, 12 goes by inches. When your numerator number, which is inches here, matches what the problem would like, you're done. So then all I do is 5.6 times 12. I don't know what that is, 70 something? $67.2. So we have 67.2 inches. If I'm worried about significant figures, I'm just going to round that to 67 inches. This number has 2 significant figures. Unit factors, you don't worry about sig figs for. It's just the starting number. You have to worry about significant figures. So since my starting number is 2, my final number should be 2. Okay, let's make it slightly harder. How many inches in, I don't know, 1.5 miles? Okay, great. So I don't think anybody knows how many inches are in a mile. That's a ridiculous number to have memorized. But some people do have feet to miles. There's 5,280 feet in a mile. And then you should know that there's 12 inches in a foot. So if you know those two things, you can solve this problem using dimensional analysis. Remember, we start with the number in the problem, 1.5 miles. I set up a unit factor. My denominator unit has to match what I start with. This setup will always be the same. Please memorize this. You have your starting number in unit, you have the time symbol, you have the dividing line of the fraction, and you have the same unit that you started with in the denominator. Okay, then I have to figure out what unit to put in the numerator. I can't go miles to inches. I don't know how many inches are in a mile. So I go miles to feet. Hopefully you can see this green color. So I go miles to feet, and then I get the numbers from the equality. In 1 mile, there's 5,280 feet. In this case, I'm not done right now because the question wants inches, and my numerator is feet. So I have to do one more. So the cool thing about dimensional analysis, too, is that you can do unit factor after unit factor after unit factor all in the same problem, so you only have to put this in your calculator once. So feet is up there. That has to go in the denominator. And then I can go to inches because that's what the problem would like. And then in 1 foot, there's 12 inches. So now I'm done for sure because my numerator, inches, matches what the question would like, inches. So 1.5 times 5,280 times 12 is 95,040. And I've got two significant figures, so I'm just going to round that to 95,000 inches. Ta-da! Great? Great. Clear ink. On to the next page. So here we have a bunch of conversions. So you have to have the three memorized for sure. Milli, milli, and centi. And then we can do these. So convert 1.8 kilograms to grams. Start with the number in the problem, 1.8 kg. Kg to grams. I can do this. If you look back in your notes packet, you'll see that there's 1,000 grams in a kilogram. Since my unit, that's all it wants. You just multiply it by 1,000, and it's 1,800 grams. This one, I'm converting 1,820 milliseconds to seconds. Again, look back at that table in your packet. You can go straight from milliseconds to seconds because in 1 second, there's 1,000 milliseconds. Now, since my non-1 number is in the denominator, now I have to divide. So now it's 1,820 divided by 1,000. So it's 1.82 seconds. And the last one on this page, I don't know how many millimeters are in a kilometer. Oops, this should be millimeters. But I do know that there's 1,000 millimeters in a meter. And I also know that in a kilometer, there's 1,000 meters. So this is going to be 56,000 divided by 1,000 divided by 1,000, which is 0.056 meters. Sorry, that's hard to read. Should probably box that one too. Okay, so then in your packet, hopefully you can figure out how to do number 1 through 4. It's going to be difficult in the digital packet. You might want to write it on a piece of notebook paper, and then you can take a picture of it, email it to yourself, copy paste it into the unit packet, and I guess that's how we'll do that. So have fun. Great job.